Hey guys, I'm Aditya Shivkumar and my project is on the train-elephant conflict, also in short known as TEC. So the train-elephant conflict is a matter of great concern in India and it is also close to my heart because it is also where I live. So coming up with solutions to such an issue and making a project on this really seemed apt for me as there is no better place to start than at home. And yeah, really glad to be getting this opportunity by the Knowledge Society, and I hope I do justice to it. So let's get right into it. But first, we need to address the fact that India is a vast country and that elephants play a vital role to many communities in India. Some people in cultural and religious ways, and others in environmental ways. Elephants are like the architects of the forest and woodland ecosystem. Many ecologists feel woodlands may even cease to exist without these elephants. I mean, like, that's just crazy. So, as we can see right here, in tropical forests, 30% of the gigantic tree species and 40% of all tall trees are home to our elephants. And as we all know, they are our nature's gardeners, and that they are key in shaping the landscape and also in things like improving the fertility of our forest soil with their dung. And seeing the number of elephant reserves in Tamil Nadu and understanding the importance of the elephant. Urgent measures to reduce their mortality rate are to be thought over seriously and they need to be discussed in public forums and in detail. And the solutions that they come up with have to be implemented properly. So now let's move on to the issue here, which is that the extensive network of Indian railways mostly cuts through these dense forests and they happen to be home to our beloved elephants. So, and they are not only our elephants, they are home to lots and lots of other wild species too. But what is happening here is there are a lot of elephant and animal deaths happening in India due to insufficient knowledge of elephant movement. And sometimes, despite knowing that there is elephant movement in an area, by the time this information reaches the respected officials, it's already too late and the damage has been done. And that is exactly what happened in this situation too. The railways was informed about elephant movement in that area, and the forest department too was monitoring the elephant herd movement throughout the day. But sadly, this incident happened in the night time, and during the time of this event, the technology that was being used to track these elephants could not monitor these at night. So this is just a sad state of affairs. And in this instance, where it seems though the forest department had installed an early warning system on a stretch of the track in back in 2018, it supposedly went defunct during this event. Now I don't see right at the time of such an event how like at the time of such an event technology could automatically go defunct, but you get the point. And well, this isn't a problem in just Tamil Nadu or the states I've been talking till now. It's happening all over India. Kerala, Assam, Odisha, and West Bengal being the prime locations for such incidents, but not the only ones. So now let's move on to what are the current solutions being implemented by our government and state governments towards this issue. So in 2017, the railways had come up with quite an innovative solution to keep the elephants away from the railway tracks used by using bees. Now, but unfortunately, data showed that this did not help much in preventing elephant deaths on tracks. But apparently, even though the plan was effective in the start, it wasn't scary enough for our Asian elephants as they had grown familiar to the sound of buzzing bees. Like, yeah, everyone gets familiar to the sound of buzzing bees, sure. So, and well, so the Tamil Nadu government recently took an initiative and by bringing AI into this picture. So they installed infrared sensors on 6-meter long poles and on trees on either side of the railway track close to the elephant corridor in the Coimbatore Forest Division, just to try this out. And well, so they implemented something called the yellow zone and red zone. So basically, if an elephant is seen in a yellow zone, an alert would be generated in the console room, and the messages will be sent out to the forest officials. And so, well, basically their classification was yellow zone and red zone. So in yellow zone, messages sent out, and in red zone, full-blown alerts and alarms are blown to alert the forest officials immediately and so that they can take immediate action. So we talked about the Tamil Nadu bringing up an initiative and bringing AI into the picture. So what is the current technology they're using to solve this? So they are brought into the picture something called the TEC. So this is basically the train-elephant conflict. So this is one of the major issues across the world which affects both humans and elephants. As a recent research indicates, many elephants and other animals die due to train accidents mostly at night time. And despite the railway authorities instructing the drivers to reduce the train speed in these areas, there has not been much reduction in their deaths. So the surveillance and the tracking of these elephants are also difficult due to their size. And the proposed system, which in the TEC is, detects the elephants with their sound, so which are recognized to be as very diverse. So the input to the proposed system is the acoustic wave generated by the elephants. So the acoustic wave receptors, which look something like this right here, are placed on the path of the elephant. Like basically they are kept around the railway tracks, so you can basically they are kept around the railway tracks. And something called the Raven Pro 1.5 software is used to analyze the acoustic data and to improve the signal enhancement. Basically a noise cancellation software. So let's talk about acoustic sensors here for a minute. So basically an acoustic sensor helps us identify different sounds in an environment. So an acoustic sensor gets its detection mechanism from its name itself. Like this detects the sound waves as acoustic signals. And these waves run through the surface of the material parallel to it. And in case of some changes in the wavelength, the velocity is monitored with the frequency of the sensor and by using its own method of measurement. And these measures of measurement can be correlated to the physical quantity being measured. And so these data that are collected by the acoustic sensors can be inputted into something known as a MATLAB software, where MATLAB is basically a programming platform designed specifically for engineers and scientists to analyze and design systems that help us transform our world. So it basically helps us do simple things like analyze data, develop algorithms, and create models and applications. And basically the key feature about this is that MATLAB is designed for the way you think and the work you do. So learning and coding is accessible whether you are a starter or an expert. So basically it's a very user-friendly service. And also using the MATLAB software which we just talked about, the recorded acoustic waves are filtered using the Raven Pro, which we talked about too. So to reduce the environmental noise recorded with the actual sound of the elephant. And the filtered sounds are tested for recorded spectrogram patterns. And once these unsuccessful match of the spectrogram patterns to the sound of the elephants, which we already have in the system, SMS will be sent to the forest officials, the station master and the respective officials. So basically this is the technology that the government is trying to apply to their sensors as well. And well, okay, let's look more into this. So when a study was undertaken on the frequent accidents, like I had mentioned before, most of these accidents happened during the night. So they had to upgrade and revamp the system a bit. So the next step they took was to add thermal sensors into the picture that could support their already existing tech to reduce the risk of failures due to the nighttime problem. And soon enough, they found that internet would be a problem too. So solar panels came to our rescue. So because once an elephant is detected, how do these signals go to the respective officials? Through internet. So these solar panels were installed to increase their 3G or 4G capabilities and make these accessible in that area. And when all of these technologies seemed really promising and feasible to me, I thought, why not try and create such a tech on my own and possibly get a different approach on or like a different solution to tackle this problem. And this is where my project comes in. So this is where I would like to bring into the picture something called object detection. So humans can easily detect and identify objects present in and around us, right? So when humans, because the human's visual system is fast and accurate and can perform very complex tasks like identifying multiple objects at the same time and detecting objects that too very easily. And while the term object detection itself may seem very simple and easy to understand, there's a lot more to this. And before we dive into object detection itself, let's talk about a few key terms in this field. So the first is image classification. So image classification is basically the prediction of the class of an item in an image. So for example, when you carry out a reverse image search on Google, example for X, so you're likely to receive a note that says this might include X, with the X being anything that the technology detects as the primary object of the image. Basically, it can just identify what the object in the picture is and not where it is. And this is basically what image classification is. And there's another segment called segmentation. So segmentation is the process of separating your data into distinct groups. A well-defined segment is one in which members of the segment are similar to each other and also are different from members of other segments. So like in this picture that we can see that cycles and cars and the road and the pillars are classified into different segments, and you can see that they are all distinct objects. Basically, it is the task of like grouping pixels with comparable properties together instead of bounding boxes like we see in object localization or object detection, which is our next topic. So object localization, so the difference between object localization and object detection is very subtle but evident. So object localization seeks to identify the location of one or more objects in an image, whereas object detection identifies all objects and their borders without much focus on their placement. So let's see on the correlation of what they are. So image classification is pretty straightforward, but the differences between object localization and detection can be confusing, especially when all three tasks may just be equally referred to as object recognition. And maybe that's just like a very broad term, isn't it? And well, image classification involves assigning a class label to an image, whereas object localization involves drawing a bounding box around one or more objects in an image. And object detection is more challenging and combines these two tasks together and draws a bounding box around each of the items of interest in the image and assigns them a class label. Together, all of these problems are referred to as object recognition. So now that we have talked a bit more about the different aspects to this technology and to object detection, let's look at the two main models of object detection, which are deep learning and machine learning. So data analysts commonly rate deep learning approaches as a state-of-the-art approach, since it is considered to be much more intuitive and does not require as much human interference. And well, in the end result, both approaches yield very accurate results, but let's concentrate on object detection with deep learning this time around. So what sets object detection with deep learning apart from alternative approaches is the usage of convolutional neural networks, or as I have mentioned in the slide, CNN. So neural networks mimics that of the neural architecture of our human mind. So they primarily consist of an input layer, hidden layers, and an output layer, like we can see in this picture right here. And deep neural networks for object detection yield by far the quickest and most accurate results for single and multiple object detection, since CNNs are capable of automated learning with less manual engineering involved. And regarding the types of CNN, there are three types: RNN, RNN, fast RCNN, and faster RCNN. So let's look at these one by one. So what is RCNN? RCNN is basically a region-based convolutional region-based RCNN, region-based CNN, which was proposed in 2014. So basically, how the RCNN works is the input image is selected, of which 2000 regional proposals are extracted. Next, the features would be extracted from each individual region, which would then go on to be classified as one of the known classes which are present in our system. So though all of this seemed very promising, the primary problem of RCNN lied in the fact that although it extracted 2000 region proposals, it was a very lengthy process. And this is what paved the way to the new and improved fast RCNN. So fast RCNN significantly cuts down on process times by inputting the image to a pre-trained CNN in order to generate a convolutional feature map, eliminating the process of breaking down the image into 2000 region proposals like in the RCNN. So the region proposals may be easily identified from this feature map, sending them to something called the ROL pooling layer, like we can see in this picture, which then extracts the features from a given region. Then the output from the previous layer is processed by a fully connected layer, like we see in the end here, where the model splits into two outputs: one for class prediction via a softmax layer, and another for bounding box prediction via a linear input. And as we can see right here, the training hours and the time for test runs drastically reduced due to this minor change. And well, yes, you were right. So soon a third and even more upgraded model was later introduced, known as faster RCNN. Yeah, they're coming up with very interesting names. So the mechanism was similar to that of fast RCNN, but with a few noteworthy tweaks. So the faster RCNN did not use selective search like in the fast RCNN, which is based on grouping among similar regions. Instead, the region propositional network would come into place to allow identifications of the origin region proposals at record speed. So that, as the name suggests, like reduce the test times, as we can see right here, drastically, and it brought it down to an unparalleled 0.2 seconds, making it the fastest ones of its predecessors, like we saw fast RCNN and RCNN, and this made it optimal for real-time object detection. So after all of this, you may be thinking that there is no faster network than the faster RCNN, right? Well, that's where you're wrong. Because in 2015, a family of neural networks was proposed with the abbreviation YOLO in reference to the notable phrase, you will only look once. And basically, the name describes itself because the network only takes one look or one pass through the network before outputting the final image. I mean, that's just incredible. And while our previous CNN networks may have had incredibly high speeds, they certainly couldn't match up to the level of YOLO because YOLO actually allows object detection with real-time footage, which is considerably preferable for surveillance-related applications and actually a lot more fields which require live footage analysis. And while the accuracy of the detected objects is lower than the previously mentioned models, that comes at the incredible advantage of exceptionally high speeds. And so without further ado, let's go right into learning more about YOLO. So YOLO, you only look once, is a one-stage object detection algorithm for real-time object detection using convolutional neural networks. CNN basically, what we just talked about. So the neural networks mimics that of the neural architecture of our human mind. So just like a human body too, YOLO V4 also consists of a backbone, a neck, and a head. So the backbone is CSP Darknet 53, which is an open source neural network framework, which basically trains and extracts the program's features. And the neck is a path aggregation network and spatial pyramid pooling, which is basically to collect the feature maps from different stages. And the head, YOLO V3, is used to implement the main object detection itself. So YOLO V4 is a state-of-the-art detector, which is faster and more accurate than other available detectors. And it's because of these precise reasons that this will be a perfect tool to solve our issue, and exactly why I'm using it for my own project too. So regarding my project, I've created a screen recording of the important functions and steps to be followed to execute this program, as sometimes it can take very long to run it. So just to concise it, I have just taken some key moments which are crucial to the working of this program. And I know I have switched off my camera as I'm going to be operating a lot on my PC, and honestly that really doesn't look good on camera. So before we start off, I would like to give credits to the programmer of this coding, AI Guy, for creating a tutorial on his code on Google Colab. So he made his program open source to take in as many inputs as he could and which will eventually better his code. So he has also included his own comments and exact steps to follow to run this program on his tutorial, which basically means anyone and everyone can try this out on their own at the comfort of their home. And that is exactly what I did too. So starting off, in his original program, he had basically used an input video file named test.mp4, which was basically had cars moving on the road with pedestrians and bicycles and everything. There's also one called cars.mp4, which also basically did the same thing. So what I did was I inputted my own file elephant.mp4, which is basically an elephant walking in a forest. Yeah, I know it's nothing too much, but at this point I just wanted to test out if this program could even recognize or detect an elephant. And also YOLO V4 already has a set of classes that you can identify or detect if you input a video containing this object. These classes are stored on this file called coco_names, right, which I just clicked here. So what we can see here is all the classes that YOLO V4 can recognize as an object, and there are already about 80 of these. And as this is open source, anyone can, if they wanted to, add another object to this 80. So how this would work is basically you would have to make YOLO V4 learn the object. So you would have to feed hundreds and hundreds of images containing that specific object, so it can learn how and where that object can be detected or identified. So basically behind each one of these 80 objects, there has gone thousands and thousands of images, and numerous amount of time has been spent to make YOLO V4 learn about each and every single one of these. So coming back to our thing, we can see that there already exists an elephant class in the YOLO V4 program. There actually wasn't much left to do, as the program already could identify what an elephant is and what isn't. And moreover, it could also locate and form a box around it, as I had explained previously. So since most of the work was already done, we move on to the steps to be taken to actually run the object detection program. So the first few steps are just classic normal steps that we would have to do in a program. So the first step includes me bringing my project to the code at hand, which is basically onto Google Colab, which is where this tutorial and the open source code is present. And the second step is basically bringing AI Guy's, the original code made by AI Guy, which is on GitHub by the way. So we're bringing and importing that code now into Google Colab interface. And well, the third step involves dealing with certain dependencies of the earlier version of YOLO V4. So I had to update and modify this part of the code a bit so as to get to the earlier version of the code. so that the program could run smoothly, as the new version didn't work out that well for me. And the next few steps are basically just bringing in some more codes from GitHub, as I had mentioned earlier. So let's just run those. And also something to notice, the original code was trying to detect all the 80 classes that we had seen in the video as input. So, and as we know, that is going to take a huge toll on our computational power and also a huge amount of time, which is something we surely don't want. So what I did to resolve this problem and to make my program run faster was I went through the code and identified the line, which identified the line and eventually disabled the line which asks the program to recognize all classes and change it to something more feasible, which was to recognize only the class we want, which was obviously the elephant class. So how we did that was we went down to the file object_tracker.py, which I just did, and opened up the code, and quite to our help, our AI guy has come to the rescue. So he has basically given his own comments to most of his lines of the code and how to manipulate them to that code to our benefit. Like we can see right here, the green lines are the comments that he has made. So I found that in line 160, we found the thing that I mentioned earlier where the program was reading all the classes. So what I did was I created that line into a comment too, so that that function doesn't run in the code, and made the line 163 functionable by removing the hash which was originally given by a guy in his code. And this made our code run only the class elephant, which reduces the load on my computer drastically and also made the processing time a lot quicker. So in this next step, we are running the actual object detection program, which is named as object_tracker.py in this code. And as we can see, it has taken the video I had inputted as its input video. So the program is going to now run on my video. And the output or the result of the program is being stored in another file named tracker.avi, which is right there. Yeah. So we can, so yeah, it's right there. So now we can see YOLO before and actually in action. See how fast it's doing its job. The speed is also due to the fact that I made that change in the code regarding the classes thing, but nevertheless, just look at it go. And if we look closely, we can see that each frame is being detected and recognized at like 25 frames per second. And well, okay, these next couple of steps are basically for the output file to be converted into a readable format, which a computer can read. So the first of these is defining a helper function, which is used to display these videos on our screens. And the next one is for converting our resultant videos from the AVI format to the MP4 format, which we can later store and download onto our systems. YOLO also shows you the generated output once the program is complete, and there it is. Our elephant has been detected by YOLO and is being tracked so perfectly, and the object localization, image classification, everything that I explained about earlier is working perfectly and on point. So now all that's left is to apply this tech in a large scale, and there you have it. So a solution to a massive problem in just seconds. And well, we should note that instead of the video that I just inputted, we could take the footage of real-time surveillance cameras placed near the railway tracks to track their movement. And this program that I've run in YOLO v4 could constantly run with the footage being fed to it by those cameras. So that will create a second-to-second check on our railway tracks, which is exactly what we need to solve our problem. And once an elephant is detected by this program, immediately an alert or a message should be sent to the respected officials who are at that time the train or locomotive drivers and forest officials and the railway managers of the respective regions, so that they can take immediate action. And this method of solving this issue, I feel, is a much more cost effective and budget friendly approach to tackle something of this scale compared to our railway plan Bs or the sound acoustic wave system that I talked about earlier. I really want to take a moment to thank TKS and Mr. Naveed and Mr. Nadeem in particular for giving me this opportunity to make this project, as this is something I've wanted to do since the very start of filling my application for joining TKS. Like, the NN Fulbright, when I first read of it, really seemed like a place where I could show my capabilities and show how interested and dedicated I can be in making a project. And I'm glad that I'm finally getting a chance to prove myself and my worth to society. But due to certain short-term circumstances, I may say, like my midterm exams this week, I really couldn't spend the amount of time I wished I could have spent doing the project. Like, I really wanted to include a lot more research and generally just spend a lot more time on the project. But nonetheless, I've given it the best shot I've got with the resources at hand and the time that I had. So again, really glad to be getting this opportunity to get a full ride into the program, and I hope I do justice to it and show how much I really deserve this. Thanks again.